Today, in this video lecture, we will see second numerical on this frame structure, and our objective is to calculate shear force diagram and bending moment diagram of this frame structure. So, first see and understand this frame. B to D total height is 10 meter and A to C also 10 meter and DC is 10 meter. And on this DC, 5 kilonewton per meter uniformly distributed load acts. And at point B, due to roller support, this By reaction comes. This is free body diagram of this frame. And at point A, due to hinge support, this vertical Ay and horizontal Ax comes. And our first step is to calculate reactions. So, first take summation of forces in x direction equal to 0, and this force is positive and this force is considered as negative. So first see this whole structure and see horizontal forces. See, this Ax is horizontal and this 10 kilonewton horizontal, and both are like this. So minus Ax minus 10 equal to 0. So Ax equal to 10 kilonewton minus 10 kilonewton. So that means this Ax assumed direction is not like this, not like this. This is like this. Ax. Again calculate summation of forces in y direction equal to 0 and consider vertical force as positive and downward force as negative. So see whole structure and see vertical forces. See, this By and Ay is vertical force and this 5 kilonewton meter UDL is downward force. So positive By positive Ay minus 5 into 10. 5 into 10 because 5 is uniformly distributed load and acts on this 10 meter distance. So equal to 0. So Ay plus By equal to 50 kilonewton. Now we need to calculate Ay or By. So for that, how to calculate Ay or By? So for that, see, we need to take moment at any point between A to D. If we take moment at A, then we are able to calculate this By. If we take moment at B, that means we are able to calculate Ay. But see, if we take moment at this point B, then this Ax, Ay both forces are comes. Then this 10 kilonewton and this 5. That means 1, 2, 3, 4 forces comes. But if we take moment at this point, then at this point, B point, see here, at this B point, then only this, see at B point, 4 forces and comes, and if you take moment at this A point, then this By, this 5 kilonewton, this 10 kilonewton, only 3 forces has come. This Ax and Ay goes through that point, that means these are 0. So this is easy for us. At point A, moment calculation is easy for us. So calculate moment here at this point. For that, summation of moment at A equal to 0, clockwise moment is positive and anti-clockwise is negative. So this By is clockwise to that point, see, goes through that point. So clockwise. So positive By into 10. This 5 into 10 kilonewton is act at middle of this beam. From this D distance it is 5 meter, and 5 into 10 is 50 kilonewton, and it is anti-clockwise to that point. So minus 50 into 5, again this is also anti-clockwise, minus 10 into 5 equal to 0. So this By equal to 30 kilonewton. Now put this By in this equation 1. So Ay equal to 50 minus 30 is 20 kilonewton. So by that way we have calculated reactions. Ax is 10 kilonewton. Here see, this is direction but magnitude is 10 kilonewton. Ay magnitude is 20 kilonewton and direction is correct, and By is 30 kilonewton. So Ax 10 kilonewton, see this diagram and see Ax Ay By. Ax 10 kilonewton, Ay 20 kilonewton and By 30 kilonewton. Now calculate shear force. For that, consider this BD beam. Always go clockwise. Consider first BD, then DC, then CA. So BD here at point B, roller support. So By equal to 30 kilonewton. So see, and here at D point, this is fixed support. So due to this fixed support, this By, every action there is equal and opposite reaction. So this is opposite reaction like this. By 30 kilonewton and downward. So see this beam like horizontal beam. This is B, this is D, this is By, and this is also By. Consider. See, let's consider this as a Dy. Magnitude is same, remember. Dy, Dy. see this BD have only axial reactions By dy, but this BD don't have transverse reaction. So due to this, there is no shear. And at point B there is no movement. That means that due to this B is roller support. So due to this at point D also there is no movement generated. So no shear and no movement at this DB. We will go clockwise direction to this DC. So this draw this DC. DC have movement. This movement is 50 kN. No, 50 no. This movement has UDL of 5 kN per meter. Total length of this DC is 10 meter. Now see, this BD is like this, but this DC is like this. So due to this dy reaction, here opposite reaction comes like this dy, and magnitude is same. Dy is 30 kilonewton, so here it is 30 kilonewton. Now calculate shear. Shear force calculation. So again draw this DC beam. This dy goes upward, dy reaction, so it is 30 kilonewton. And calculate reaction at this C point. So this positive goes upward, so positive 30 minus 5 into 10, that means positive 30 minus 5 into 10, that means minus 20 is at this C point. And see this AY is also 20 kilonewton. This 0 is at the center of this beam, because see this is, so this is 20 kilonewton. I will show you that this point is at a distance of 5 meter. Why 5 meter? But it is center of this beam. Total length is 10 meter. Center is at 5 meter. See this positive dy and minus 5 into x. Consider this distance as x equal to 0. This dy is 30 kilonewton minus 5 into x equal to 0. So 30 equal to 5x, so x equal to this is 30 kilonewton, so minus 5 into x, so 30 divided by 5, so it is 6 kilonewton. So correct it. This is not 5 meter, this is 6 meter. Now calculate moment. At point D there is no moment, because see here dy have no moment, so here d also have no moment. We need to calculate here at mid at 6 meters. See, this distance is 6 meter at middle portion. So here, so this is clockwise to that point, so positive 30 into 6 minus 5 into 6 into 6 by 2, it is 90 kilonewton meter is movement comes. And this is parabolic curve because of this UDL. Here 90 kilonewton meter. And at point C, calculate also at point C also. Positive 30 into 10 minus 5 into 10 into 10 by 2. It is 50 kilonewton meter here. So like this. Now calculate for this CA portion also. So due to this C is at point C 50 kilonewton meter clockwise movement. So here also 50 kilonewton meter clockwise movement generate. And due to this AY, here this is fixed point, so opposite reaction 20 kilonewton generate. And here C AX 10 kilonewton. So shear force for your understanding purpose, see this beam like horizontal beam. Here A, here C, here 10 kilonewton X. Just rotate this beam like clockwise, like this here. So 10 kilonewton, here 20 kilonewton X. Here movement generates 50 kilonewton per meter, 50 kilonewton meter. And this is reaction, axial reaction 20 kilonewton. So draw shear force here. This is 10 kilonewton this side. So see like this 10 kilonewton downward, that's why negative. So minus 10 between C to D, between A to D there is no load. So here see 10 kilonewton load acts at a distance 5 meter from roller support. 5 kilonewton and 5 meter, 10 kilonewton and 5 meter. 10 kilonewton and here it is 5 meter. So positive 10, and this is like this, 10 kilonewton. Again goes upward, and this is like this. So here also minus 10 kilonewton. This is SFD. Now draw BMD, shear force diagram, bending moment diagram. This is A, this is C, this is A, this is C. Now see, this 10 kilonewton meter is anti-clockwise movement, so minus 10 into 5 minus 50 kilonewton, and here no load between A to, consider this as X point, between no load between A to X, so it is inclined line minus 50 kilonewton up to here only, to 5 meter distance from A, minus 50 kilonewton meter. So again see, minus 10 into 10 plus 10 into 5 minus 50. But see, we are making mistakes. Always consider, always calculate shear and moment here from C to D, from top portion to bottom portion, from here C to D. Because of errorless calculation, if we go from here, see, so this C at C clockwise 50 kilonewton meter. That means positive 50 kilonewton meter. So here it is positive 50 kilonewton meter. Now calculate at this X point. So again it is only positive 50 kilonewton meter. Calculate at this A point positive 50. This A point is anti-clockwise to that, so minus 10 into 5, so it is 0 here. So it is 50 kilonewton meter positive. See, we are coming from like this, right to left. So here think D to B. This our beam rotation is wrong, I think. This because see, if we come from right to left, then this is at C. This is positive moment, so positive mx, positive 50, that means mx is negative 50. So I think here rotate this beam like this, C to A, like this. Top side is first C to A. At C there is 20 kilonewton, sorry for noise disturbance, 50 kilonewton meter. and this 10 is downward, 10 kilonewton. This is X, this is AY. This is X, this is AY. Now see, this 10 downward, this is negative. That's why I write here negative. So this is correct. And here this is positive clockwise. That's why here positive. So positive clockwise minus 10 into 5. Here it is 0. So yes, rotate like this. Top point is first point. So by this way, our SFD BMD is complete. See a shape of shear force diagram. BDCA. So at BD there is no shear and no moment. 30, 20, 90, 50. So here it is 30, goes like this. 30, 20, 10, 10. This is minus. Minus is inside that BMD shape. So here it is like this. Minus 10, 10. Unit is kilonewton. Now draw BMD also. Bending moment diagram shape. This is shear force diagram. This is bending moment diagram. This is B, this is D, this is C, and this is A. This is 50-50. Positive unit is kilonewton meter, and here 90-50. We will see this in StatPro also. Here at a distance 6 meter from this point D, it is 90 kilonewton meter, and at a point C it is again 50 kilonewton meter. Positive. So see this in StatPro software. At point 1 it is 0. Second node is 4 meter. Second node is 10 meter. And at y direction it is again 10 meter. Here it is 10, 10. View, geometry, add beam. Define some property. Rectangle 0.23, 0.45. Add clothes. Assign to view. Assign. Yes. Now material is concrete. Assign to view. Assign. Yes. Support. One is roller support. And one is pin support. So load case details, add live load case 1, add close load case 1, add member load -5, add close. Add concentrated 10 kiloton load also. For that gx and it is minus direction gx. Add close. Add select and location is 5 meter away from that roller support, hinge support, sorry. This assign to selected wave. Assign. Yes. Now analysis it. Run analysis. See deflection, shear, see shear 30 20 10 10. So here 30 20 10 10. Yes, it is correct. Now see movement. It is minus 89.9. It means it is 90, and see it at which distance it is 90. At 6 yes, see at 6 meter it is 90, not at 5 meter. At 5 meter it is 87.5, and at 6 meter it is maximum. So our calculated BMD is correct. Now annotate beam result. So C 50-50. Yes, it is correct. So this way our SFD BMD for frame structure numerical 2 is complete. Thank you very much.